let's find every x value where the line tangent to this curve is horizontal. Okay, let's interpret that question. Find every x value, final answer will be x values, at which the line tangent to, okay, a line that's tangent to a function represents the slope at that function, at that particular point. And I want that line at whatever x value to be horizontal, which means the slope is 0. Here's what the question is really saying. Tell me everywhere that the derivative equals 0. Give me all the x values. That's it. So let's just find the derivative. And all I have to do is find the derivative. 6x squared, 42x, and 60. And I'm going to set that equal to 0. Again, I'm looking for everywhere that the line tangent to a function is horizontal. So we have some sort of cubic function that probably looks like that. And I want to know where the x values are, or what the x values are, where this would be the case and where this would be the case. So set that equal to 0 and solve it. Let's factor out a 6. We'd have x squared minus 7x plus 10 equals 0, and we will factor this one. X minus 2, x minus 5. There we go. So we have two answers. Obviously 6 equals 0, that's not a thing, that's not true. But x equals 2 and x equals 5. And it's at those two x values where we have horizontal tangent lines. Okay, as we go to the next problem, we're going to see a little bit of a difference. And here's the next problem. Number 6 says f of x equals 2 over x. That's going to change our derivative. It's going to change everything. So 2 over x. Well, before we take a derivative, let's do a rewrite. So this is really 2x to the negative 1. So I want to set this equal to 0. Well, I want to set the derivative equal to 0. That's not the derivative. That's a rewrite of the original function. So now we find the derivative. Negative 2x to the negative 2. That's really negative 2 over x squared. And we're going to set that equal to 0. That is not what the graph of this one looks like. The graph of this one, 2 over x, actually, we'll draw it in red. It's going to look a little bit like this right here. And I want to know where the horizontal tangent lines are on that. So we set this equal to 0, and it doesn't really take too long to realize that you're not going to get very far in solving this. If a fraction is equal to 0, then it's the numerator that equals 0. Well, your numerator is negative 2, which equals 0. Well, no, it doesn't. That's not true. So if this is not true, then this is not true. And so there are no such x values. So there are no x values where the derivative is equal to 0. It's not going to happen. And if we look at the equation, we look at the graph, we'll see that we don't have a place where the function is exactly flat, so to speak. So it's going to get leveler and leveler and leveler, but never fully level off because of the asymptote. And that's going to happen on both sides.